Hello, I'm Robert, a science blogger and fact checker, and I've taken recently to fact checking stories that scare people and to help people in the Doomsday Debunk group that I helped set up on Facebook. And nowadays, an awful lot of them about climate change. And we just get one story after another, week after week. Every week we have several stories that I have to debunk that are scaring these people, just exaggerating to the max and beyond in ridiculous ways. And that's including ones that are sometimes by scientists too. And this is an example. I don't know why they do it. I think perhaps their idea is that if we make things seem really, really scary, then people will act quickly. But it doesn't work like that. It just paralyzes them with helplessness and despair. It's not the way to do it. And psychologists look into it, and it is not the way. What you've got to do is to help people see realistically what the situation is, and then give them positive, motivating stories to show that we could show people examples of people of actually doing things that have worked, and showing that we can actually deal with this. Because it's entirely true, we're doing massive amount already. We're not doing enough, but we're doing a huge amount already, and there's vast potential. So anyway, let's look at this story. It's called Climate Tipping Points, Too Risky to Bet Against. And maybe I'll bring it up in the... So I'm using this academic web annotating tool to annotate it. I can bring it up here, but maybe it'll be easier to read here maybe, but we'll still have a look. So there's the story, you see, and then I've on Nature, and then I've annotated with this academic web annotating tool. So you can see, for instance, it'll be easier to do back, but I'll just show you how it works. So they start off, the first point is here, click there. And we think several cryosphere tipping points are dangerously close, but mitigating greenhouse gas emissions could still slow down inevitable accumulation of impacts and help us adapt. What they're talking about there, cryosphere, means ice caps and things like that, and glaciers. And these melt, but they melt incredibly slowly. It's just very, very difficult for ice to melt. It's got a whole lot, huge thermal capacity. And it just takes thousands of years. Even at business as usual, if we continue to produce all carbon dioxide, which is impossible, all the way through to 2200, then still it would take until 3000 for the ice in Greenland to melt, and the Antarctic ice takes far, far longer. And on the path we are now, we're talking about thousands, tens of thousands of years. So, I say, and we have ways that we can take carbon dioxide. There's already one possibly practical way. It hasn't been very thoroughly investigated yet, but using giant kelp farming. So I'll just bring that up. And this is an idea of, I'm just going to talk about this right so now. There's my video about giant kelp farming. So this is something that's already been done. It's called aquaculture, seaweed farms. These are seaweed farms near South Korea. Each of these little blocks is a seaweed farm. And seaweed farms take carbon dioxide out of the atmosphere. So, and they're dark, so they don't really show up when you have these looking at the greening of the planet. So you get this study of how much the planet is greened. It's also browning in the seas. And that is a significant increase in carbon dioxide sequestration as well, which doesn't come up, isn't sort of noticed often in satellite photos. Look how many there is in South Korea. Vast amounts of seaweed farming. It also happens in, and let's do this without any sound. This is a project to do seaweed farming in the he's doing it in the US, and here's someone else, another one, and then they're doing kelp as well. Kelp goes in all sorts of different places, and this is the whole general idea. You could have scallops, mussels, seaweed, oysters and clams, all of that, just in the deep ocean. Right in the middle of the Pacific you could have stuff like that, or in the middle of the Atlantic. This is shown near a coast, but you can eventually roll that out, even in the deep, deep ocean. And one of the things that's rather nice about it is that you get, it's called eutrophication, which is when you get runoff of fertilizer from farms, and also from like fish factories, fish fish farms as well, because the food they give them, you get the runoff from it, and that makes the sea too rich, which takes some of the oxygen out of it. Well, these seaweed farms can take that up as well. So they're great for removing that. They also reverse the acidification of the oceans. It's one of the few ways we have of actually reversing that. And instead of just taking carbon dioxide out of the air, they take it out of the ocean and out of the air. Out of the ocean first, they're actually growing in the ocean, taking up the carbon dioxide from the ocean, not from the air. But because the ocean then is depleting carbon dioxide, it then takes it out of the air. So it's only indirectly taking it out of the air, and it's doing it by reversing the acidification of the ocean locally, which then takes it up from the air. And so then one person has worked out, and that if 6% of the ocean surface was covered in giant kelp, could remove 100 parts per million of carbon dioxide in 50 years, and 9% could remove that much in 30 years. In other words, from 400 it could go back to 300. That's a huge, huge change. So, and they suggest starting with sheltered water like the Mediterranean, Gulf of California, because then you use storms, and then if a quarter of all the sheltered waters, that would be 0.3% of the ocean, and so that's 0.3. What was it we had here? That 9% would be. Where was it? 9% is equivalent to. Wait, I was just reading it out a moment ago. Where was it? Oh yes, 9% of this. 6% could move 100 parts per million in 50 years, and this is a kind just in sheltered waters. Then what was it? 0.3%. No, where is it? Yes, there we are. So 0.3%. So 3% could move 50 parts per million in 50 years. So that would be 5 parts per million in 50 years. So that's already quite a useful amount that you could start removing by just covering 0.3% of the ocean. And then they think it would be possible to build it up if you had the project that's at the same level as the Polar Moon project, but costing less than it. And that's because it's low technology and requires little by way of infrastructure. And the thing is also that this is actually, it's very minimal impact, low impact. You have to be careful about certain things, and about not causing algal blooms by sort of stuff being, so that there's the best things you have to be careful about if you set this up properly. But you set it up with a nice, well circulating system, and carefully designed, then they reckon they would have no impact on the oceans, and it would take vast amounts of carbon dioxide out of the atmosphere, and it would there would be plenty of nutrients for it, and it would and take vast amounts of carbon dioxide out of the atmosphere, and it would be maybe a practical thing to do. And then it would produce also lots of fuel. So it produces zero emission fuel, and also produce food. And so, I mean, that obviously you need to look into that. So whether we can do that this century, but what they're talking about here are things that would unfold over centuries to thousands of years. And I mean, that kelp thing, it certainly looks feasible, and paper about it looks feasible at present, and maybe we can't do it this century. But if not, surely sometimes, then that's not just one idea. There are dozens of ideas of how we can do it. And surely sometime over the next few thousand years, if we want to take carbon dioxide out of the atmosphere, we can. I'm sure we can. Who knows what technology we'll have. I mean, I couldn't have guessed what technology we'll have now. 50 years ago. I wouldn't have had a clue. I would never have guessed smartphones, or cheap computers, or electric planes, or all the wonderful things that are happening now. So who knows what we'll have the second half of this century. Maybe we can remove carbon dioxide quite easily. So what really matters is not these long time scales. What matters is far more is the next 10, 20, 30 years, where there are important things that we have to try and stop. Anyway, I think I'm going to go back there. You've got the idea. That's how it works. And if you click on that, I meant to do an open new window. I'll make those into open new windows. If you click on that, it'll take you to in context on the page itself, so you can actually read it in context. And if you click down, and then if you look down the page, you'll see other ones. You just click on them, and you can see what the annotation is for that, and for that. It's a very clever tool. You can annotate anything on the web with that. Anyway, so so whether or not you can do these in a sustainable way, it's certainly a possibility that at some point in this century, we can certainly do it in the next several centuries or millennia. I'm pretty certain of that. I don't know how we're going to do it, but sure, one way or another. And then they go on to say, so I'm just going to annotate various things. Modelling suggests they could add another 3 to 4 meters to sea level on timescales beyond a century. Again, this is very long timescales. And over the next century, that's several centuries. Somewhere I've got one of the projections over longer time periods. But we're most interested in what happens in this century. And over this century, this is a table from the most recent report of cryosphere in the ocean. And we've got a prediction of even at the 4.9 degrees C, and we're more like this, 0.39 to 0.72. It's not very likely to go above a meter before the end of this century. And then you get the regional sea level rise, which can be a little bit bigger. And so, we're a bit above 2.4 degrees C. But so now, and if we look at the 1.5 C thing, and that's what that is. These are fractions of a meter. And you see, it's a little bit bigger. Like Florida is quite a little bit bigger, and so that would be maybe half a meter, even the 1.5 degrees C. Because you get various amplifying effects. The warming of the ocean expands the oceans. If it's warmer, then it goes a bit higher. And also, being furthest away from the melting ice, Florida is very far away from like Greenland or Antarctica, and the melting ice, as it melts, it reduces the gravitational effect of the melting ice. It's quite extraordinary, but the amount of gravity just from the ice, if you could remove mountains, you could do the same. But as the ice melts, then the ocean actually spreads out. And so actually very close to Greenland and very close to Antarctica, you can actually get reducing sea level rise as the ice melts, because the gravity is no longer humping it up. The gravity of the ice is no longer humping it up around those continents, around those islands of continents. And this is the opposite effect. But another thing you get is you get the slight slowing down of the Gulf Stream, and that pushes water up and raises the sea level around the east coast of the United States. Just very slight slowing down. The Gulf Stream sort of pushes water across towards Europe, and the reduction of strength of the Gulf Stream causes it to come back towards the United States. So quite a lot of things, and these are quite difficult, complicated maps to do. And so that's partly why Florida, and so Florida is one of the worst affected by sea level. And but it can be mitigated. In the whole world, it's one of the worst. And it's especially worse. It's quite ironic actually, because Florida is, of course, where if I bring up Florida is, of course, where Donald Trump has his Mar-a-Lago resort, and his resort is right close to the sea, and it's been one of the worst places affected by sea level rise. It's quite extraordinary that so this shows this is Mar-a-Lago resort as it would be with 1.8 meters sea level rise. That's not very likely, but and in that at that level, that's a 12-foot rise, 12 feet in 12 feet in meters. I think that's about That's 3.5 meters. But that, remember that. So now if we go and look back at this, at the climate tipping points thing, and now if we looked at the business as usual, have I got business as usual? That's down there. Then you get over a meter, well over a meter up there. Yeah, it's not likely to go as much as high as that with the latest projections. But what was it again? 3.5 meters. But anyway, the ironic thing is that Florida is built on limestone. It's just the bedrock is limestone, so you can't keep the sea out. So you couldn't use Florida, Netherlands style dikes to keep the sea out of his property. We would have to move it. You have to lift the buildings up and raise the land or something if you wanted to protect it. So anyway, but until then, there are various ways, because this is only at the highest tides and and during what do you call them, storm surges. Then the sea really rushes in, and so you need to remember that the sea level rise is first going to affect places at high levels during storm surges. And the various ways you can just kind of slow down the storm surges, even within Florida, even though you can't keep it out indefinitely. But you can slow it down a bit. You can have little you can have kind of sponges and barriers is the idea. And you have the kind of sponges that absorb the water. So as the storm surge comes in, these absorb enough of it to kind of slow it down a bit, and you can have to kind of various sea marshes and things. So things you can do even in Florida, but most places it's much better than that. So if you go and look at go pop up, and so now this is Bangladesh, and Bangladesh, people outside Bangladesh have been saying, oh, they're going to lose lots and lots of land because of sea level rise, but they're more sanguine about it in Bangladesh themselves, because what they're discovering is that also the glaciers are melting in the Himalayas, and this glacier melt is bringing more silt down their rivers. So they're actually getting new islands forming at the same time as they're losing some of them. And they're actually gaining land so far. And that's not going to continue indefinitely, because the glaciers are melting, but that means eventually there are less glaciers. They're melting because of climate change. So you're getting more water for a while, but eventually the glaciers are gone. Or as much as it's going to melt, it will have melted. That's about a few decades from now. After that, then they'll stop getting this new silt coming down. But they're making the best of it as they can. They're putting little breakwaters in to kind of catch the silt, so it doesn't all go flowing out to sea. And then they have the option of making polders, like in the Netherlands. And the Netherlands, and that was quite low tech, because if you think about it, the Netherlands, they had it with windmills and way back, centuries ago. So even though Bangladesh isn't the wealthiest of countries, it can do some polder making already, and it can do more if it gets a little bit of help with the Green Climate Fund. And then in the Netherlands, then they have various things. Now, one of the problems is, of course, you've got rivers that are going down and going out. Then as the sea level rises, those rivers are going to rise. And so that is going to be flooded back. Now, you can, of course, they have embankments along the rivers. You could see this sort of kind of embankment. The river is actually raised around the surrounding land. So, and you can't cope with it by just raising all the rivers. And then you have these kind of various lakes that forms in there. If you get a lot of flooding, then you've got to pump it out. So part of the problem is the drainage of the lower regions. Now, what they're doing in Rotterdam, they're not so much raising the banks of the rivers. That's quite difficult to do. And what they're doing instead is that they have these barriers that keep out the sea when you have very high tides, and then they let the water out in the daytime. When tide is low, not in the daytime. And then they have flooding various parks and things and lower areas when these blocks are across. and those are the kind of the sponges and barriers idea. So these various sponges that they identify areas that they can fill with water, and if you've got enough large areas of that, you can capture either the rivers or the sea or the incoming sea. And so these ideas of the clever Dutch engineers are being exported around the world and help people around the world to deal with the sea level rise. So we have to do both, adapt and mitigate, try to stop it by reducing the amount of CO2 emissions and also adapting. And but eventually, there's no technological barrier to how high the sea can rise. This is a 300-meter high embankment, and so even if the sea rose 300 meters, you could, in theory, if that was the sea rather than a lake, you could hold back the sea even 300 meters rise of the sea. If you have good embankments, you have a lot of confidence in your technology, and you're just pumping water up, then you have all your rivers in kind of raised up channels, with the rivers kind of pouring down those channels into the sea. So, in principle, you could deal even with, and it's nothing like 300 meters. You could even deal with that would be 10,000 years in the future. Who knows? Maybe the Netherlands is behind, 10 meters high, but it's already 6.5 meters, it's getting over 7 meters below sea level, and you add another 10 meters, another 20 meters below sea level. It's not impossible, eventually, over thousands of years, and that's what they decide to do. On the other hand, we might do something like the giant kelp and just stop it happening. And really it'll be up to us what we want, or rather our descendants, our generations, great-great-great-great-great-grandchildren. So you don't need to worry. And if you look at this map that I got up here, this plan, then they look at the adaptation at different rises. That blue that's the 1.5, and that's the business as usual. And then this shows the megacities, and as you can see, the tick is with adaptation. So you really don't need to worry about megacities at 1.5, except Miami. That'd be even a business as usual. Only Miami really, and big cities in Florida. They're the only ones really. There's hardly anywhere. It's very rare, it seems, for a city to be built on limestone near the sea. As far as I know, Miami is the only one that anyone ever talks about in the cities in Florida. And so at this kind of level, you're starting talking about, but we're hopefully we're going to stay down here somewhere. Then at this sort of level, and we don't know. It's hard to correlate, but with a very high sea level rise, you're talking about possibly quite a few people having to migrate away from Florida, or else they build up, and they sacrifice the ground floors of their buildings, and of only the ones that are very low lying, and they build their roads up. Or they have boats like in Venice, so that's a rather unlikely solution. Now, if you look at the agricultural deadlifts like Bangladesh, then with adaptation, then they're pretty okay as well. And then that's Arctic communities, again, adaptation, it makes a big difference. That's with moderate effects, and these are the high and very high effects. So, it costs much less to mitigate than to adapt, but the adaptation is feasible. For the world as a whole, it costs much less for the world as a whole to adapt, to mitigate, to stop the carbon dioxide emissions. In fact, it can almost cost nothing. People talk a lot about the renewables, but you've got to remember that all the fossil fuel infrastructure has to be replaced by new fossil fuel infrastructure eventually. Tankers have a lifetime of 20 years, cars have a lifetime of about 15 years, fossil fuel plants 40 years, but an awful lot of the cost in a fossil fuel plant is in the first, is just building, is the fuel, and so it's already becoming uncompetitive, and it's likely that an awful lot of the fossil fuel plants just stop running in the next decade or so, because they're being competed with renewables. It's already not looking very good for them, and the renewables are getting cheaper and cheaper, projected to half in price again, and they're already competitive with fossil fuels. And so and they might well halve in price again after that, because it's hard to predict the technology already gone down 4 times in price in 8 years. Bound to halve in price again. We can see how to do that. Probably halve in price again. Wouldn't be surprising if 8 years from now they were a quarter of the price of fossil fuel plants. There's no real reason. It's not actually clear that this has slowed down this reduction in price. It could be that 8 years from now that renewables are a quarter of the price of fossil fuel for the electricity, for solar plants. But you can't rely on that yet. We can rely pretty confidently on it going to half the price in sometime in the next decade. Right. Models suggest that Greenland ice could be doomed at 1.5 degrees C. It happened as soon as 2030. This is a little bit confusing. Actually, I see it in context. It doesn't mean that the Greenland ice sheet. So, and the 1.5 C of warming, they have not understood that. I haven't actually mentioned that in the annotation. The 1.5 C, actually, 1.5 C of warming can, in a way, happen in the next, it could happen this year. It hasn't. It could happen any time. There's 10% chance of 1.5 C of warming, of the average warming of the world, happening before 2023, according to the Met Office. This does not mean that we have failed with our pledges, because they're talking about the average over 30 years. And so you only really know at the end of 30 years what your average was. So it's not really possible that we could know by 2030 what the average is, and reaching an average of 1.5 C by 2030, I think that's really very, very high up in very low probability. But as we are, and the IPCC report in 2018 was very much misunderstood by many. It didn't really say that. It was much more saying every half degree matters. It wasn't so much that 1.5 degrees C is a magic number, and that we've got to be exactly at 1.5, and if we go to 1.6, then that's going to be awful. But that wasn't really what it was saying. It was saying that if we can reduce the temperature by half a degree by 2050, then that will make a huge difference to the corals, and make a huge difference to the amount of heat waves and to the amount of hurricanes and wildfires and so on. And it is well worth putting an awful lot of money and an awful lot of effort into that. And it really is going to save an awful lot if we did do that. That's what they were saying. You don't need to get too hung up on the numbers. It doesn't, whatever emissions we do, if we do the amount of reducing emissions for 1.5 degrees C, and then we end up being at 1.6 or 1.7, you don't need to worry about that. The main thing is that we've saved all the half degree above that, which makes a huge difference no matter where we end up. And so yes, so that was that. Yes, see it in the page. It could add, yes, it's a bit confusing. It could add a further 7 meters to sea level over thousands of years, as you see. And models suggest it could be doomed, but as you say, it's future years, and that same still this timescale is still under our control. So if you read this very carefully, 1.5 degrees C would take 10,000 years. Above 2 degrees C could take less than 1,000 years. I'm not sure. I mean, this research from 2019. It's very recent research. I'll have to double check what they said, but their site. But this said that it was the lowest of their kind of likely range was complete melting by year 3000 for business as usual, which is CO2 emissions continuously to 2200. And this is what happens with low emissions by 2000. That's by 2100. That's by year 3000 with low emissions. As you can see, there's hardly any change. And this is a feasible path we can approach. But so these people are saying that we can't, but as we'll see, there isn't really anything to that. There's nothing new. There's absolutely nothing new in this report compared with the IPCC. And nothing new. They're just always emphasising the negative and forgetting the positive. That's basically how they're doing it. So now they say several of which involve sea ice. They're talking about tipping points, a cluster of abrupt shifts. Well, not really, not for climate, not for the average climate. The IPCC report actually says the opposite. It says the sea ice is often cited as a tipping point. Detailed modelling, however, suggests that some ice can return, and it is not. It is neither reversible nor bifurcation behaviour. It can quickly equilibrate the end of century climate under an overshoot scenario. In other words, if you go a bit over to 2 degrees C and then go back, the ice will just return to the way it was. So I'm not sure. The thing is, they don't really explain where that comes from. There's no section number. It's just a site. It doesn't. I'm not quite sure where that comes from. So in fact, let's see if the site. Yeah, several of which involve sea ice. So they don't give a site for several of which involve sea ice, and they just give a site for just 10 to 35% chance. It's the same. They have quite a lot of things they just don't cite. They just say things, they don't cite them. So it's very hard to know. These IPCC models, what is that about? They don't really explain. And there's some things where they've just got it wrong. So the reason the reason the Arctic is warming faster is not because of the melting ice, but it's because this is even in a water planet. And I explained that before, and you can just read that. But this is actually, as the Arctic ice is melting, more heat is absorbed, and you get more clouds in the tropics. Way back in the 1989, when Thatcher gave a talk to the UN, then people did think it was a possibility that the ice melting could be a tipping point. But with the careful modelling since then, it's not. We get more clouds in the tropics, and the world as a whole, actually, the more it warms up, the brighter it gets, the more reflective. And so it's not a tipping point, because these blue patches more than compensate for the red patches in the Arctic. And actually, the albedo change in the tropics is far more important, because you get much more sunlight here than you get in the Arctic. And so this reflects much more sunlight, and this also absorbs more. The Arctic ice isn't really that important for the world as a whole. And the reason it warms up is because of convection from the pole, from the tropics. And the reason the southern hemisphere doesn't all warm up so much is nothing to do with the melting ice. It's because of the westerlies and the various other effects, but one of them is constant westerlies across the Pacific, which stop getting so much convection southward. And so that's why the temperature doesn't increase so much down here as it does up there. But so as the world warms, the tropics get warmer, you get more convection in a warmer world than in a cooler world, and so quite a lot of the heat of the warming is lost to the Arctic. But then it's blocked this way, so you get even more going to the Arctic. That is why the Arctic is warming up so much. The albedo effect is a very minor part of this. So now, and they talk about estimates of where Amazon tipping point could range from 40% to just 20%. That is quite out of date now. There are some people still doing articles like that, but the latest reviews, even back in 2017, so they're a couple of years out of date. Then the Royal Society review said a recent work from 2016, so they're 3 years out of date. So possibility of a transition, but not in a continuous rather than a tipping point manner. And resilience may be underestimated if you don't. So the early models, they just had 2 plant types, and they didn't have any variation in the ages of the plants. Very, very simple model of the Amazon, and that's what led to this threshold behaviour. And more modern models, they don't have this anymore. It's much more continuous. And so gradually, as we warm up, like sort of about 3 degrees C or so, then parts of the Amazon do gradually turn into more of a savanna, but without human intervention. If you're just talking about what's happening anyway, then human intervention and logging kind of helps accelerate this a bit. but it's not going to make a huge difference in this whole area that is shown in green. At the end of this is the last glacial minimum. That was what was left of the Amazon. This is what we will have at the end of the 21st century of the area that is still high tree cover. And this is low tree cover, it's not all the trees gone. And so it's really quite a large area. So you don't, this is kind of pretty safe, whatever happens, apart from human logging. So no. I'm going to come back a little bit more about that. And there's various review articles. And then, now they talk about North American boreal forests potentially turning some regions from a carbon sink to a carbon source. This is the same kind of cherry-picking thing. So one thing they're missing out here is that as the Amazon is deforested, large areas of the world are being reforested. And generally over Europe, over Northern America, over China, over Asia, there's a huge amount of reforestation going on. It's only Africa and South America that are currently deforesting, on average. Of course, both is going on. You get deforesting as well as afforestation, but the net change is positive in the way of more forests over most of the world. And the Africa and South America are lagging behind. But they can turn around. They probably will turn around sometime in the next decade or two, because they've got huge reforestation problems, things going on there. For instance, Ethiopia, you must have heard the 318 million trees that they planted. So that's an African project. There's the African, there's a sub-Saharan green wall, plant vast numbers of trees south of the Sahara. So there's all these huge projects to plant new trees, and they've just ignored those in their loss due to the Amazon. I'll talk a bit more about that in a minute. So Northern American boreal forests, and again, remember we're planting lots and lots of forests in North America and in Europe and in Asia. And if you look at the overall biomass of the entire Arctic region, it's actually increasing. An increase in above ground tundra biomass about 90.8%. That's quite a lot. Between 1982 and 2010. And some areas are browning, but most areas are greening. So there's really so the boreal forests consider to support the browning of forest vegetation, but this related to the fractions of evergreens and deciduous trees, with greater kinds in evergreen. And so deciduous trees, they're doing pretty well, but the evergreens are browning. And this is a general tendency that we have throughout Europe, that the forests are changing from evergreen to deciduous. And then the deciduous trees, they're eventually going, the next generation of deciduous trees are going to grow up and replace the dying evergreen trees. I haven't actually explained that in this comment here. And so, and we can manage forests, and you can actually do something about that by planting more of the appropriate trees for the next generation. And for instance, one example, Iceland. Iceland is one of the most deforested places in the world, because it used to be covered in forest 1,000 years ago. And then the people came there and cut down trees, and their animals went around and ate trees, and it's all gone, pretty much all gone. But they're now growing trees again in Greenland and returning Greenland to forest. So that is one area of reforestation, which haven't got marked here as anything, but Iceland is a huge area of reforestation at the moment in the Arctic region. And this is just a very new project, last few years or so I think they're doing it. They have got greenhouses full of little saplings which they're planting out, and appropriate ones, so they have to be careful when they plant out these saplings that they choose the right ones for the slightly warmer climate that they're going for. Of course, very cold still compared with where I am in Scotland, but it's much warmer than a fair bit warmer, because they're in Arctic, they're warming up much more even than in Europe, and because of the, and of course Europe is warming up more than the tropics, and that also explains this bit about that against due to convection. It's obviously not due to ice melting because we don't have large ice sheets, but we are still warming up a lot because of the convection from the tropics. And so you have to think, and the UK is doing a big regrowing of, and we're certain all the parties, which is a rather nice thing for the next election, all the parties they're vying on how many trees they plan to plant each year. The minimum is for the Conservatives 30 million trees a year, up to 100 million for Labour. And so we're certain to have at least 30 million trees planted every year in the UK, starting from this year. And so that's quite a vast forest. It's going to be gradually, they're going to double the forest cover with the higher pledges, and to significantly increase the forest cover in the UK. So the UK is another very denuded country. I live in Scotland, and you see the trees, the mountains, very impressive in Scotland. What you don't realise is that to someone who was living here a few thousand years ago, and they came now and they say, "What's happened to all the trees? You've cut down all our forests." That's what they would say. And they were cut down in many different ways. Originally, it was all covered in ice. And then the ice was, when we retreated at the end of the Ice Age, then you had tundra, and then you had forests, vast forests grew up. And then if you could get an ancient Iron Age people from the UK, you could bring them forward into the forest, future, into the same place they used to live. Say, "What have you done to all our forests?" And they've all gone. That's what they would say. Because there were vast forests covered the UK. A squirrel could have gone from one side to the other, and from north to south. And they've all gone. They've gone cut down to make ships, cut down for iron smelting, cut down for agriculture in the early centuries, and then they had the grazing of the sheep going over the mountains. You also had we made the wolves extinct. Just a few centuries ago, they killed the last of the wolves in the UK, and the wolves used to eat the deer. And without wolves, then the deer grow out of hand, and the deer eat the trees. So it's one of these rather unintuitive connections that by making the UK wolf extinct, then they helped with deforestation, because the wolves were helping stop the deer from eating all the trees. One of these rather funny little chains of causality. So with the wolves gone, then now we have to have humans control the deer. They could use contraceptives, but it's really quite difficult to do. And so that's why you have hunters hunting the deer. And that's because if it weren't, then the deer would just starve. They don't have natural control of their population. They just grow and grow and grow, and they eat everything, and then they start starving. They get in a miserable condition. So it's just not ethically right to allow deer to do that. So that's about that. So now, yes, next one, release carbon dioxide, methane. They said that as the permafrost thaws, then it's going to release carbon dioxide and methane. Now, this is really a rather confusing way of putting it, because there isn't any carbon dioxide or methane trapped in the permafrost. Not the ones they're talking about on the tundra. Maybe, it could be a confusion with the deep Arctic, deep sea permafrost. It could just be a lazy way of putting, just a rather careless way of putting it. They probably knew what it actually meant, but it could confuse the reader. Could get the impression that there's carbon dioxide and methane trapped up in the permafrost. There isn't. There are organics from grass and animals, and as it thaws, then they decompose. But if you think you're putting rotting grass and animals, that's how you make compost, and you put it into your garden in order to make it nice rich soil. So in good conditions, this just makes the soil rich. So that is why it's so extremely difficult to predict what's going to happen there. It very much depends on the conditions. So if it's kind of rather damp conditions, very, very damp conditions, and the organics are close to the surface, then the methane can bubble out. If the organics are deep, covered with a lot of water, then the methane isn't going to get to the surface. It's all covered with water deep down and then drier soil on top. Then the methane, as it goes up, will get eaten by other microbes and never get to the surface. And then if it's very dry, you produce carbon dioxide, but again, that can all be absorbed and eaten, used up. And you have trees on the surface, they're going to start growing, and shrubs growing, and grasses growing, and that's taking up carbon dioxide. And it's extremely difficult to know what's going to happen there. Is there going to be a carbon dioxide source, or is it going to be carbon dioxide sink, or generally greenhouse gases sink? And nobody knows, even on business as usual. Now you keep getting these stories that if you just follow the press stories, you will assume that the scientists are certain that it's going to be a source, because now these are all the publications that said that that the blue is moderate and red is high emissions. These are the years that they were published. These are the ones that say it's a source. These are the ones that say it's a sink. See, back in 2018, you still have that's a high emissions sink. It's high emissions, very slight sink. Very slight sink, and higher sink for low emissions, as you'd expect. And then one say it's a very big source. And then, high sink again. So you get all these publications going both ways. It is not yet decided. We had another one in 2019 says it's a sink. But we might get another one later this year says it's a source. It is just not settled. And it could be, and we can change it. For instance, if lots of Arctic fires, then that could make all the difference. That could make a difference one way or another. And we can choose that. We can choose whether to stop the fires or let them burn. And we should let some fires burn, because the Arctic depends on the fires. We can do things by blocking the drainage in order to get peat bogs. And peats as they grow take carbon dioxide out of the atmosphere, but it takes a lot of skill and knowledge to do it properly, to know how to modify it. But this is also, it will depend on human actions, whether accidentally or on purpose. It depends on how we burn, how much of fires and where we let fires burn and where we stop them. You need fires in order to create new growth for certain kind of animals that actually depend on them, like the owls and voles and they all depend on grassland and the what's it called? Some kinds of herbivores depend on the clearings in the trees from the fires. So and then, as I said, yes, this is a recent thing. So they're going on about the methane there, you see, and the released carbon dioxide and methane. Greenhouse is 30 times more potent than carbon dioxide. So, and this people keep coming up. Methane is 30 times more potent, but it depends how much methane there is. And methane is released in very small quantities compared to the anthropogenic emissions of carbon dioxide. And even when you talk irreversibly and release carbon dioxide and methane, they might take it up. But if they do, and there's also you hear about the Clathwaite gun hypothesis, but that's effectively disproved now. There's some methane from the sea floor, but it's been going on for millions of years, and so and that is in the very worst case here includes the most pessimistic scenario for everything, including the most pessimistic scenario for methane from the Clathwaites and everything, and that doesn't necessarily correspond to business as usual, but it probably is the highest emissions. So these are human emissions. This is an increase in human emissions of methane. That's 1,000. That's not 0, just so you don't get confused. That's 1,000, that's increased with human emissions. And this is how we can reduce. And then this is the difference. So remember, there's another 1,000 down there. So this goes down quite a bit. And so there's a small increase in methane. This is the worst from the Arctic, of all the methane from the Arctic, all the sources in the Arctic, the tundra, the lakes, the permafrost up in the sea, all of that. That's the worst case. So this is human emissions prediction with current policies, and this is what if you do very strong reductions. And if you increase on the very strong reductions by the worst case there, then it's still only a slight increase on human emissions, but remember you've got this 1,000 below here, so it's not really a big change. So it is significant. You're talking about like quite a big country probably, but it's not as equivalent of numbers of emissions, but it's not significant in terms of global emissions from humans of all things. The total of this is just the methane. This is not the carbon dioxide. It's just the methane emissions, and this is already contributing to current temperatures. So if we can reduce, it's helped to mitigate. It's helping to reduce. If that comes down, it's reducing global warming. Because this is a constant level. This is the actual constant level in the atmosphere of methane. That's what that graph is of. So there, it's just barely changed from now. Then you reduce the carbon dioxide emissions, then stop the emissions from getting any higher. And stop them from getting too high. Then this is not doing anything. So yes, that's the extreme. Tundra and lakes increase markedly, extreme increase in ocean emissions. So now an Amazon dieback. So now they talk about that back to Amazon dieback and see another 90 gigatons of CO2. Then what you've got to remember, as I said, there's global afforestation going on. And I talked about all that before. But also, even in Brazil. So in Brazil, by 2025, then there's probably going to be no more pressure on they reckon by 2025. This is just an attempt at an integrated model for Brazil. Now they are middle of the range scenarios. It's just a projection. You can't say this is actually going to happen, but it's a moderately probable. It's quite a probable thing. It's kind of middle of the range possibility. Just looking at it's assuming a very modest increase in the crop yields. Meat production from 1 to 1.7 by 2050. They could, with a really focused improvement of the like seeding, newer policies of reseeding grassland and so on. They could go up to the US levels, which are higher than 2 heads per hectare. They could do that much more quickly than that with a very focused program to increase the yields. And the crops again, 1.5% per year, then that could be increased with very focused policies to increase yields. But just suppose a very modest increase, they're not going to have a huge program about it, then they reckon by 2025, then there's an awful lot of available land which is just being freed up. So we no longer need, Brazil would no longer need its small farmers would no longer need to go and cut down the forest, because there'll be loads and loads of abandoned agricultural land that's just going to seed, just not being used for anything. And so if all that land was reforested, then that could take up again all the carbon dioxide that's been lost since, I think they said 2005 or something, peaks. Yes, so it liberates 6%. Oh yes, here we are. That is with reforestation. Sugarcane doesn't work so well. So if they could reforest all that land, then they can get a larger area than was deforested. Then, of course. Then do I give? The original carbon stocks of felled areas by 2035. Yes, so all the stuff from 2010, all the deforesting since 2010 could be recovered by 2035, and then you increase on that by going. So the new forests grown in Brazil, there would be like tropical rainforests along the rivers, for instance, but they could, if you just were to completely reforest all the abandoned land, then even though they're not as big forests as they were originally, they're not as it takes an awful lot of time, centuries or decades through to centuries for the larger trees, to get all the way back to the richness of a tropical rainforest once you've felled it, in terms of just the amount of biomass. But the decades at least, and then to get all the way back is like you've got the ages of the very older trees. But if you have a large area that you can reforest, and so Brazil, there's no reason at all why Brazil, So their whole thing about, that Brazil is going to lose this 90 gigatons or whatever they said. Where is it? There we are. Happens to die back at least another 90 gigatons, but it's actually very optimistic. We're not expecting the runaway thing, the tipping point of Amazon. It's a very slow thing, and we can do this. And it's not going to be difficult for Brazil if they just they're not actually felling. They're felling, even if they go back to 2010 levels, they're still not going to fell all the Amazon for ages and ages and ages. And as we can see, by the mid-2020s, then long before this significant more amount has been felled, then they're going to have plenty of spare land. So it does look quite optimistic. So now we go back to here. They mentioned these Dansgaard or Oscar events. Well, these, whatever they were dependent on the fair. They're probably just quasi-regular. These were very dramatic, sometimes with 10 degrees warming in a few decades. But this was only because the Earth had huge ice sheets. And when a planet has large ice sheets, the climate is more unstable. But it's not the global temperature that was changed anyway. It was only the temperature in the Arctic, and during these events it would warm up very much in the Arctic, but the southern hemisphere would cool. And then the Arctic gradually cools and the southern hemisphere warms, and the global temperature wasn't all that much changed. And anyway, whatever they are, these events, they can't happen now. They just can't happen now. So it's very much non sequitur. So what does it matter? We know, if you know a bit about climate change, then climate is very much more unstable in the middle of a glacial period. Those large ice sheets just make the climate much more unstable, and it's actually quite good being that if we have probably added enough carbon dioxide to prevent the next ice age, and our great grandchildren may well thank us for that, because it means they won't have to deal with this climate which is constantly changing. I mean, a 10 degrees C rise would have meant nothing. It wouldn't have been too big of a deal to whatever humans were back then. They might have to move a bit or something, but it would become more difficult for industrial civilization with agriculture. So it's really quite good not to be in an ice age. Now this one, a cloud resolving model. So this, I've got loads of news about that. Lots of mistakes about it. If you read the abstract, then if you read the abstract rather quickly, and then didn't look at the paper itself, then it gave the impression that you might get your 8 degrees warming above 1,200. It didn't give their 1,300 figure. But if you look at the paper itself, it says eventually at sufficiently high greenhouse gas concentration, so it just starts to break up at 1,200, and eventually at 1,300 parts per million. Then the stratocumulus decks break up into cumulus clouds, and then you get the dramatic surface warming. But they also say they ignored some interactions that would likely increase that to somewhere between 1,400 and 1,200. So this is in case you don't know the background, the idea here was that this was a paper that there was a bit of a puzzle, that there have been times in the past we've had the same amount of carbon dioxide as we have now, and yet it was much warmer. Or not much more carbon dioxide than we have now, and yet it was much warmer. And why is it much warmer? All that ice melting doesn't do it. So the IPCC found in 2018 that even all the ice melting in Greenland and the Arctic would not give us the extra half degree. It increases the sea level, but it doesn't increase the temperature much. And the temperature increase may be due to this cloud effect. And so this was it's just one paper, and I haven't found any follow-up research from it yet. So I don't know if it's been confirmed yet. This is early stuff. You've got to take this and it's not really relevant. I don't think IPCC are looking at this because it's just not relevant on the timescales that they're interested in. So they're probably not going to pay too much attention to this. But I suppose we have to look at the next report and see if they say anything about this. But it's just not going to happen on those timescales. But if we were to do business as usual all the way through to the 22nd century, that's not going to happen. That's just not going to happen. We're not going to let the world warm up that much without starting to do something very vigorous about it. It's just inconceivable that all the things that they predict would happen at those numbers of parts per million would happen, and we just do nothing about it. We're already doing a lot, and we're not likely to get anywhere near that. But if we could go all the way up to 1,400, so the 1,300 parts per million, it ignored some interactions. That the large-scale substance in the troposphere, that you've called they're coming down, then that weakens under global warming, and in the troposphere. Yeah, I don't know. I can't remember from the paper. I have to reread the paper, but there's this difference in how the troposphere behaves. It's an effect that gets weaker under warming, and so this will counteract the instability. And so this instability, which they got at 1,300, but didn't parameterize this thing, which they know would weaken it, which make it higher than 1,300. And they don't know how much higher, but somewhere between 1,400 and 2,200 parts per million. And we just can't reach that in this century, even if we tried hard, even if we just were to keep up the carbon dioxide levels up at the levels they are now. So that really is not relevant to us at all. So now they say many more results are pending, but to us these preliminary results hint that a global tipping point is possible. This is about the new climate models. So yeah, maybe I should explain that on the page a little bit. But if you see it in context on the page, it's about the new climate models. I should have a screenshot that shows that shows a little bit more of that paragraph. So we have these clean new climate models that are running too hot, but they don't fit with the paleo and instrumental data. And so this has happened before, that sometimes the climate models run too hot, sometimes they run too cold. One model for an entire year showed no warming at all. And this is just because it is very, very difficult to couple up the details. And because it's a chaotic system, and it's very difficult to match up the small details matter. Tiny, tiny details make a big difference to the whole thing. And it can be quite difficult to couple the details with the whole thing. And you can't model everything. So you have these kind of factors that's kind of join them together. I'm no expert on this, but I don't know how it works. But I do know that they have to tweak and work with their models until they get them working right. And that isn't perfectly legitimate. That's scientific. It's not just fudging. It's not fudging the data. That is actually how you do the modelling. And that is how they managed to do weather forecasting. They couldn't do weather forecasting even for the next day very well. They didn't do stuff like this. And then you calibrate it by looking at how well your models fit the data. So just as we now get very reliable weather forecasting, because they worked out how to take the measured instruments and turn them into the model, and then deal with the models and all the uncertainties in the model in ways that eliminate this sort of effect. So and then you calibrate the long-term climate models with the modelling the ice ages and modelling what has happened in the last few decades when we've had very good instrumental things running it again, predicting the future and then checking that your predictions happen. So all this data that they've got, then the new models are not fitting with them very well. So they have to try and fix that. And it's not very likely. In fact, in the future, as I say, the observational constraints still suggest 3 degrees C for the environment, the equivalent the climate sensitivity. And the next report probably won't lean as heavily on models as past reports did. Look at other evidence. and including a large study which is in preparation that uses ancient climates and observations of recent climate change. And it's also not likely to give equal weight to objections from all the models, but weighing the results by each model's credibility. So some models are more credible than others. And you need a lot of validation of the model itself. Say, oh, this model is very well validated. This works extremely well. This model, oh, it's not so well validated. It sort of works. And it's quite good. And you can have a model that could be, for instance, very good at doing the climate for Europe, but it's not so very good for the world as a whole. It's very good in the details. And that seems to be what these models are doing. They are very, very detailed. And having lots more detail is enabling to look in a lot of detail at local regions, but it's some reason it's not getting a good clear picture of the world as a whole. At least that's one interpretation. So no, that doesn't actually tell you very much yet. Now here's the next bit. To err on the side of danger is not a responsible option. Actually, that is correct. It's the precautionary principle. And say one activity. When activity raises threats of harm to human health or the environment, precautionary measures should be taken even if some cause and effect relationships are not fully established scientifically. And perfectly good. That is actually why they set up the IPCC. So they could have back in the 1980s, they could have said, well, some scientists say that global warming is going to be very harmful, and some say that it's not. And nobody really knows. Let's just assume, let's just be positive and optimistic and assume that nothing's going to happen. We don't need to investigate this. Let's just forget about all this. So that would be not taking precautions, not being precautionary. Instead, they said, well, I mean, if the ones who say a lot's going to happen are right, then we really could be in some trouble, and it could be quite expensive and difficult and problematic. So we've got to research it. So we set up the IPCC, and that is why the IPCC was set up, because of the precautionary principle. And we still have the situation that some cause and effect relationships are not fully established scientifically. For the corals, for instance, it's not totally certain that 99% will be gone at 2 degrees C, but there's enough cause and effect. There's enough cause and effect relationships. You can see the possibility that people take very seriously the possibility, which is quite a strong one, but not established totally, that 99% are gone with a 2 degrees C rise, which would make it very difficult for the reefs to recover again. So, but what it doesn't say is that precautionary measures should take to prevent any claimed catastrophic event, even if the scientific evidence is against it. It doesn't say that. And people often use it like that. They claim a scientific event that goes against the science and say, but I know this sounds very improbable and there's absolutely no scientific basis for it. But by the precautionary principle, we should assume that this is possible. That is not what it says. It doesn't say you've got to listen to junk science or implausible, improbable, unlikely and unbelievable science. So that's just sensible. I mean, you don't design the Golden Gate Bridge for a tsunami of 300 foot, like in the San Andreas Fault movie, when actually the highest scientifically credible tsunami is 16 feet, which is the actual state, those are the actual figures. And that's the same here. We don't design our response to climate change around some absurdly unlikely sudden, not only absurdly unlikely, but not scientifically credible at all, sudden increase, when the science doesn't support that at all. So it's only if some cause and effect relationships are not fully established. It doesn't say that if the scientific evidence is against it. So they haven't made any change since the IPCC. There's absolutely nothing here that is new since the IPCC report. The cloud study is new since 2018, but that is not relevant to the time period, or indeed if we stay within any credible, even at 3 degrees C, we don't come anywhere near that 1,400 parts per million. So the cloud study is just not relevant. And then we say, if damaging tipping cascades can occur and a global tipping point can't be ruled out, it's an existential threat to civilization. And I mean, this is the thing where these people are very ready to say that civilization could collapse. But they haven't, and again, that's not cited. You go to the paper, go down to the existential threats, there's no cite, there's no number there, and there's no argument behind it. They've just got several statements like that. As I said, it's not cited. There's no paper. They haven't got a paper that explains in detail how it could be an existential threat to civilization. And the IPCC don't say that. They're just saying it, from nothing. No, it's not. It could be an existential threat to several small island states and some local communities. The IPCC's own example of worst case. So I said it's not plausible that we keep producing carbon dioxide all the way through to 2100. That's just not credible. And because we, at current levels, because we are bound to act, and we are already acting. Their worst case was that the Paris Agreement falls apart in 2020. That is not even remotely credible at the moment. Here in the UK, Europe, with more and more support. China, a bit of a lapse because of the trade war, but they gave quite a strong commitment earlier this year. And it's obviously that they're continuing. Don't worry about all the coal plants in China, because they've got a rather strange economic situation there, where they're producing lots and lots of coal plants, but they're not increasing the total amount of coal-fired power. All the plants, they've already got far too many plants for the capacity, and they're all running at less than capacity. They're building more plants that are running even less capacity for some strange economic reason, and they're probably all going to be retired. Most of them are going to be retired pretty soon. So them building coal plants doesn't mean anything. For some economic reason, it seems to make sense. So several small island states give up hope of survival. This is their very worst case by about 2100, and the general health and well-being of people is substantially reduced compared to 2020, and continues to worsen over the following decades. So what you've got to bear in mind is that 2020, our health and well-being is hugely increased since the 1960s, when I was a child. Worldwide, the life expectancy has increased by 10 years in developed countries, 20 years in the least developed countries, and child mortality way down. In sustainability goals, clean water for everyone is increasing on that. We haven't got it yet, but far better than it was. And so what they're saying is that the sustainability goals, they could be reversed, and we could end up going back. That is the worst case. It is not a collapse of civilization. It's a collapse of societies such as the small island states is the very worst case. And some local communities, like people whose homes are flooded or whatever. It is not a collapse of civilization. Nobody in the kind of high level reviewed, popular reviewed climate literature is saying that. IPBES did another very high level review, and they say we'll continue to feed everyone, but the worst case is a biodiversity reduced world. So I've talked about that before. You can have a read of that. And this is Harmut Arnold about how we can feed everyone, no matter in every scenario. I don't want to spend too much time on this. It's getting quite long, so I'll speed up a little bit with the rest. Right, we argue that the intervention time left to prevent tipping could already have shrunk towards zero. They have not established this. There are no new research findings here. And the IPCC report, they said that anthropogenic emissions so far have contributed 0.8 to 1.2 degrees C, and that the emissions so far, that the sea level will rise and associated impacts, that will continue just for thousands of years, unless we do something about it. These are unlikely to cause even a long-term warming of 1.5 degrees C. This is me summarising them, this is not them. This is my paraphrase of what they said. You can read the summary yourself. And and that with high confidence it's not possible over the next few decades that you get long-term global warming of 1.5 degrees C. So they said very clearly there, we have not got enough anthropogenic emissions to get to 1.5 degrees C if we can manage to taper off. And this is they're showing up the different paths, and that's the worst. But 1.5 C path, and going up there, what is that? 1.5, and that's 2 degrees C. So that's the worst case. So what they call 1.5 degrees C, and this is the grey area, is that's doing both the global and the non-CO2, like the methane, reduced. That's that which peaks then sort of comes down, and they're saying that and this is they're saying that that's a feasible goal, and we can definitely get there. Oh yes, I quoted it from them. This is from somebody from policymakers, so you don't need to look it up. The warming will continue to, but these emissions alone are unlikely to cause global warmings of 1.5 degrees C. And they've got high confidence that it's unlikely to cause further warming of more than 0.5 degrees C over the next 2 or 3 decades. High confidence. And medium confidence that long term they won't cause 1.5 degrees C. And there's nothing in this paper, in this new Nature comment, to go beyond that. Nothing to change anything in that conclusion. And this is about the baked-in temperature rise due to the masking effect and it's just a 0.15 degrees C is their best guess. Not even as much as half a degree for the amount that is baked in because of the masking effect and then you can counteract that by reducing methane, as I was talking about earlier. If we can reduce methane and we don't get all these emissions from the Arctic, then that, the extreme level of emissions from the Arctic, then we will be able to remove that hump and not even get the 0.15. And then this bizarre statement, again, is completely unsighted. See, no sight. The reaction time to reach cheap net zeros is 30 years at best. They're just not cited. And there's no reasoning. They don't explain. No paper, not even one sentence of explanation. And there are many countries already targeting zero emissions by 2050. The UK is. And then all the opposition parties, 2045 for SNP, so that means below 1.5, 2030 for the Green Party, and in the 2030s for Labour. So that would be 10 years, far less than 30 years. And Bernie Sanders, his Green New Deal is 10 years. So globally, in 2020, if you were super optimistic and you suppose that China comes up with some grand new policy that is going to make it 1.5C compatible, we could get quite close to 1.5C. We're already at about 2.9 according to Carbon Action Tracker, others say 3.2. But if we could knock like a fraction of a degree off, there's no reason why we can't be getting close to 2C anyway with our next round of pledges if we have really strong pledges. And we could do 1.5C if people were very, very strong. But that's how it's expected to go because, China, it'd be extremely difficult for China to pledge 1.5. The US, of course, is only going to do that if they get a new administration or a really big change of heart of Trump. But it's certainly feasible, it's scientifically feasible, it's just the politics. And so, this is not the reaction time if you have very lazy politicians and people not strongly asking them to do that. That's really what that is. And this the average time of scrappage of a car was 30.9 years, an oil tanker 20 years. And so over 20 years, then all the oil tankers are going to be replaced anyway, or they're gone because they're not needed anymore because you're not moving oil around. for the no longer using fossil fuels for your power stations or your cars. And then I think that could happen in 20 years. It could be that 20 years from now we don't have any more oil tankers, or hardly any. Just for oil for plastics and a few other things. And could be in 20 years that all the cars are electric vehicles and they don't need oil. So that could, in that case, that could just happen by natural replacement in 20 years. All that could be gone. That's 2040. So 20 years is a very feasible target. And then you have the fossil fuel power stations, but they can just they're most of the expenses during the running, not the creation, and they can just taper out and they become uneconomic, and they stop and they just close down. And that could happen very quickly. That could easily happen in the 2020s, that nearly all the fossil fuel power plants are just stopped running. And that would actually be economically valid. You make your new renewable solar panels, especially as they get cheaper and cheaper. Imagine solar panels a quarter of the cost in 2028. It's a possibility. Then it makes much more sense to make a new solar panel power plant, and get your electricity at a quarter of the cost than it is to keep your fossil fuel power stations running. If that was possible, it just no longer makes sense to keep any fossil fuel power plants running. You just have, if it does go down to a quarter of the cost, if we have this fourfold reduction again in the next 8 years, then it would just make literally no sense at all to continue to use fossil fuel, and they just all be gone. And things can change very quickly like that. And like everyone now has mobile phones. That was a big change, very quick. Everyone having personal computers was a quick change. It was surprisingly few, not many, much by way of decades, from almost nobody to everyone having one. And so nearly everyone. And so already, just on current technology, there's 74% of the coal-fired power stations in the US are at risk, and more than half of them, then they would actually cost, the renewables would actually cost 25% less than the coal. So that's going to happen already by 2025. But it could go faster than that. And that's without any incentives. And remember, we've actually got quite a strong incentive for fossil fuels, and we could easily retire them sooner with some incentives to favour renewables. So it's nothing scientific, and nothing economic, nothing political to prevent us increasing pledges to achieve net zero by 2050, and in 2022, so the world was net zero by 2050. It's scientifically entirely feasible for the entire world to pledge to be net zero by 2050 in 2020. It'd be quite hard. Russia's not likely to come in. China is not very likely to pledge that, although it could, if it was really took a very, very strong stance, because it's already delivered. It's proved it's capable with its huge renewables industry. It couldn't have pledged it in 2015. I think it could now, and the US could. But then, when we have future pledges, if we can pledge to 1.5 degrees C with a constant increase, then 2025 we could pledge to reach zero emissions by 2040, say, and then by 2030, 2035. 2035 doesn't seem a very unrealistic target. Finland already targets 2035, and unlike Norway, which targets 2030, they don't want to do it with carbon credits, but entirely through internal changes. And Bernie Sanders, his plan for US targets 2030. It's well worth looking through that and reading it. Look, he got a lot of unfair criticism by people who didn't understand. His idea is that the US would build vast numbers, the government would build vast numbers of renewable power stations. Now, these power stations, it is of course a loan from the future, but if you were a private individual and you could take out a loan, and you were capable of taking out, say, £1 million loan and build a power station, and you got backers who who's willing to put £1 million into your project, that could be a quite sensible, commercially viable thing to do. And then over the next decade, then you'd expect to get most of that money back, and then after that you're earning on it. Next 15 years. Well, Bernie Sanders' plan is for the US government to do that. So that over the next 15 years, it will get all the money back that it put into all the renewables it built over the entire US. And then after that, it would not take much more back after that. It would then have almost free, very low cost energy after that. The US government would say, right, we've paid for the building of all our renewable plants. Now we'll only sell the energy, the electricity, at the price it costs to maintain the plants, which would be a very low cost, because it doesn't cost much to maintain renewables. And so then the US would have dirt cheap electricity, which would be a great benefit for everyone, and including the industry. So that's Bernie Sanders' plan. It's more interesting. It's quite interesting. It's well worth looking into. If we wanted very ambitious plans, then something like that is not impossible. The main question really would be: is it going to be undercut by hugely reducing future development of renewables? But the renewables we have so far, they gradually pay off with high prices early on, and as long as it's paid itself off within 15 years, then if the new generation of renewables is costing costing only a quarter or even a tenth eventually maybe, then it won't matter because they've already paid off all those renewable plants. So anyway, right. Oh, have I doubled that? Oh, I've duplicated that. I think I have. Never mind. Oh, I've gone to duplicate the whole thing. Oh, did that happen? I'll deal with that. So I think that's me finished. I think I did a bit of silly duplication of something. Let's look at the article itself. So, is that me finished? Action time tweet. Oh, was there anything more? No, that was the end of it. Okay, so I'm finished. So I'll deal with that duplication. That was just some silly copy and paste mistake. And so yes, and so then I've said at the end the importance of positive motivation. So I've been following this since the 60s, when they thought we might have a next ice age. And I look at the reduction in renewables, like I was telling, fourfold decrease in the solar panels in 8 years. And so this is the thing about this sort of paper. I think maybe I don't know how these people think when they produce papers like this, but maybe there's some kind of idea behind it. If we look really at the worst side of everything, then we can motivate people. That is not how it works. We need to motivate ourselves with positive messages, and then this talk may help you. And I'm told that this is very sound psychology. So I suggest you have a look at that video, and then video some good things happening in the world. So I was talking, I do have a look at these videos. Those are the Greenland, Iceland. Look, they're the Greenland. That's the Greenland.
What I love about working in forestry is the chance every once in a while to get out of the office and walk in the woods.
So these are reduced sound. This is forests in Iceland. We don't think of it as being forested. And a nice long video. They're producing vast forests then. All these other places where they're growing forests I was telling you about is in China, and the reforestation of China, and the reversing desertification, and lots of wonderful, wonderful projects happening all around the world, everywhere. This is where I live. They're reforesting, not my particular part of Scotland, but in Scotland they're rewilding with these Scots pines. And Uganda, so much wonderful, wonderful things happening in the world. And that's seaweed farms. These are that's ice, new artificial ice stupors to collect water in the Himalayas. Reducing waste makes a big difference. The floating farms in Bangladesh, conservation going on in Australia, and lots of wonderful renewables projects. Wind, electric cars, electric planes. That's going feasible. Carbon dioxide, ways of carbon mineralization. This is carbon dioxide capture from a steelworks. Eventually, this sort of thing works. That could be used, taking the carbon dioxide and convert it into concrete or various other useful things. Ocean cleanup. So yes, do have a little. There are loads of things you can look at there. So that's basically my video. I think I might add this as a link to it. Add this as an embedded video to it. And I'll put the link to this in the description. Now, if there are any errors in this, if I've said anything in this that's mistaken, do please say in the comments. Let me know, and I will do have a look in the description if you've watched this video. If there's anything mistaken, I will correct it in the video. I also do little annotations, which they're rather strange. They're actually YouTube polls, because it doesn't let you do proper annotations anymore. But you see a little question mark up at the top. That means that I found something that needs to be corrected. Click on that and you get this. It looks like a poll, but it's really an annotation. It's meant as an annotation. It'll tell you it'll correct whatever I said. And I'll put that in the description. So don't hesitate to say if I said anything wrong, anything mistaken, please let me know, and I will add it. I can't modify the video now it's done, but I can. I'm going to upload it to YouTube, and you can't modify a video once it's uploaded. But I can add these annotations up to 5, and then I can add corrections to the description. So anyway, I hope this helps a few of you and help you to realise, things are far more positive. This certainly, it did not deserve all the news stories about it. It is the journalists do not understand the very provisional, and this is yes. So this is basically this is a kind of politics, science politics. It's most like a politician giving a political speech. And you don't expect a politician giving a political speech to give a kind of overview and high-level review of the things, both sides of the arguments, and whatever is wrong and right with whatever they're saying. They present the things, they're very, very focused on this is what we should do. And then it's for other people to then say, but what about this and what about that? I mean, honest politicians will talk about some of the drawbacks of what they say and then how they're going to deal with it. But I mean, that's what it's like with science. You get these people think, oh, it's nature, then it has to be totally above any question, totally unquestionable. And I think some journalists respond to some of the nature comments like that. They just think, oh, it's in nature, it must be right. It's not like that. Nature is if it's a proper, like a sign, not a nature comment, and the various other kind of nature things that are kind of these more like so it's almost like nature science gossip or science political speeches or something. You have and you can tell the difference. So I was complaining about all the lack of citations, but I mean this is really not so much. I mean it's really that it's not the type of, because it's a nature comment, you don't really expect everything to be cited. If it was a proper science like the ones that someone who's worked on their doctorate for 3 years and they turn into a Nature paper and it's a big highlight of their life that their research got published in Nature, then practically every sentence will be cited. Those sort of proper Nature papers are very heavily cited and extremely carefully reviewed. But this is not quite like that. It's obviously not carefully reviewed. They haven't gone through and said, you've got to cite that, because where's your cite for, like I said, several of these things, where's your cite for then this is an existential threat to civilization? There's none. It's just an opinion. And it's not actually based on anything. as far as I can tell. It's just an idea. It's extremely speculative, based on nothing, and certainly not in the IPCC. And they haven't given anything else. They haven't given it, as well as these, and so as a quote, there's a quote from the beginning. Let's go back to the beginning. So I did give one quote here, right at the very beginning. Their position is speculative. There are no new research findings presented here. And that was Professor Mike Hume from Cambridge University. And emergencies are declared by legitimate political actors, not calculated mathematically by self-appointed scientists. So this is a very kind of critical down thing. You're just saying, just don't think of these. This is not. This is just someone making a very. It's back, and that is it. They're basically, it is science politics. It's not proper science. And that's why he's getting at. Emergencies are declared by legitimate political actors, and this is scientists trying to act as politicians and telling us you've got to declare an emergency, and doing it by exaggerating the science in a very slanted, politically biased way. And he's sort of activist. It's very activist, and it's basically, it's not far off the message of the Extinction Rebellion. I mean, especially that bit about this could be taken from the Extinction Rebellion. Existential threat. They don't go as far as to say humans risk being extinct, which is even more absurd. But this is an existential threat of civilization. You don't get that in proper scientific papers. I mean, if it would be cited, be explained, they would say, that this reason, and this reason, and this reason, and this reason, that civilization couldn't continue, and you wouldn't be able to support a statement like that. It doesn't even make sense. Our civilization is very distributed, and the sort of things that they're talking about, widespread literacy, widespread understanding of technology, anybody could rebuild a jet plane, even a spaceship. The knowledge is there. And North Korea has done it, with very, very minimal, could pretty much by themselves, with some old Russian missiles that they had to base it on. And this would be a very distributed civilization. There's absolutely no way that anything like this something like a collapse of civilization just can't happen with the sort of things they're talking about here. It's just not possible. And but there is a risk of going backwards on the sustainable development goals, and going back to somewhat like it was when I was in the 1960s, and we just must not let that happen. It wasn't too bad living in the UK. We have things good here, but some parts of the world it was absolutely awful. And we just mustn't let that happen. We should continue proceeding in the sustainable development goals, and increasing the reducing child poverty, ending zero hunger, fresh water, clean water for all. And incidentally, at the same time, we absolutely doing what we do. We're also at the same time dealing with all the problems of farmers and so on and the droughts and all the heat waves and so on, and that's throughout the world, in the developed countries as well. For us, it becomes an expense, and people losing their jobs, but still being able to eat. It's not really such a big, not really people dying of starvation in places like the US or the UK. But for us, it's more like a big expense that we risk. So absolutely we have to do a lot we have to do this. And the corals, and 200 million people in a wonderful biosystem that's significantly at risk. And there's so much that it's so important to, in my view, it's so important to do something about climate change. But I really don't think it helps, and we are doing a lot. And it's very optimistic, with a huge decrease in the cost of renewables. It becomes far easier. And we can do this. And we don't need this extinction, existential threats. We don't need all this blarney about existential threats. We don't need that. So anyway, hopefully this helps. And I say, if any mistakes, just say.